Hi everyone! Today I'm going to go through some practice problems that use the sum and difference identities for sine and cosine. To do these practice problems, we're going to need the sum and difference formulas for sine and cosine. The first one we have is the sine of angle A plus angle B is equivalent to the sine of A times the cosine of B plus the cosine of A times the sine of B. The difference formula for sine is the sine of A minus B equals the sine of A times the cosine of B minus cosine of A times the sine of B. Then there's addition and subtraction for cosine as well. So we have the cosine of A plus B equals cosine A times cosine B minus sine of A times the sine of B. The difference formula for cosine, so the cosine of A minus B is cosine A, cosine B, plus sine of A, sine of B. These identities are definitely things that you're going to want to write down and be able to reference throughout this video. So pause for a moment if you need to do that. We're going to need the unit circle to help us with this problem. You'll notice that the problem says sine of 19 pi over 12. And so we're trying to find the exact value for sine or the exact y value on the unit circle for that angle of rotation. We don't see 19 pi over 12 on here. In fact, none of these radian measures have a denominator of 12. So what I'm going to do real quick is I am going to change every single one of these to have a denominator of 12. I'll explain the first quadrant and then I'll speed through the rest. So to change pi over 6 to have a denominator of 12, I'm going to multiply this by 2 over 2. So we have pi times 2, which is 2 pi, over 6 times 2, which is 12. Here, I'm going to multiply by 3 over 3 to make a denominator of 12. 3 times pi is 3 pi. Here, I'm going to multiply by 4 over 4 to make a denominator of 12. 3 times 4 is 12, and I have 4 pi on top. I'm just going to continue this around the unit circle real quick. The first example problem we have is the sine of 19 pi over 12. Now we're working with angle sum and angle differences. So we either want to find two of these radian measures that add to give us 19 pi over 12, or two of these measures that subtract to give us 19 pi over 12. Take a moment and find two pairs. One that I saw really fast is 9 pi over 12 and 10 pi over 12. Those things add to give 19 pi over 12. You may have found a different pair. There's lots of different pairs you can do. So I'm going to rewrite it like that. Sine of 9 pi over 12 plus 10 pi over 12. Now, this is how we can see this. And now I'm going to change it back to things that I see on the unit circle. So I have sine of 9 pi over 12 is equivalent to 3 pi over 4. And 10 pi over 12 is equivalent to 5 pi over 6. Because this is a sine and this is added, I'm going to use the angle sum identity for this. Here that is one more time. Now that this is here for convenience, we're going to see how this relates to this. When I look at this, 3 pi over 4 is going to represent angle A, And 5 pi over 6 is going to represent angle B. So the first thing we have is the sine of A. So we're going to write the sine of 3 pi over 4. Then we have the cosine of B. Angle B is 5 pi over 6. So I have cosine of 5 pi over 6. Plus cosine of A. So we have the cosine of the first angle, 3 pi over 4. And then we have sine of B, which is 5 pi over 6. All right, now I just come to my unit circle here. So the sine of 3 pi over 4, so find 3 pi over 4, that's here. Remember that star, that's the y value at that spot. This is square root of 2 over 2. The cosine of 5 pi over 6. What is x at 5 pi over 6? It's negative square root of 3 over 2. Plus the cosine of 3 pi over 4. The x value there is negative square root of 2 over 2. And sine of 5 pi over 6, that's the y value there, that's 1/2. So now I'm going to simplify. Square root of 2 times negative square root of 3 is negative square root of 6. I can just multiply underneath the radicals here. 2 times 2 is 4. Plus square root of 2 with a negative out front times 1 is just negative square root of 2. And again, 2 times 2 is 4. Because these both have the same denominator, I can put it over 4. And I can write negative square root of 6 plus negative square root of 2. So the sine of 19 pi over 12, the exact value for it is this right here. Let's do another one. The next problem we're going to try is the cosine of 5 pi over 12. Again, we're going to reference this unit circle that has all of the radians written in twelfths, and we're trying to find two things that add together to give us 5 pi over 12 or subtract to give us 5 pi over 12. So take a moment to find something that works. Something that I see is 3 pi over 12 plus 2 pi over 12. So what I have is the cosine of 3 pi over 12 plus 2 pi over 12. And if I write that with its original radian measures, I have the cosine of pi over 4 plus pi over 6. So what I need to use is I need to use a cosine sum. I'm going to take a minute to write that over here. Let's fill in the A's and B's, where everywhere this is A and this is B. So I have the cosine of pi over 4 times the cosine of pi over 6 minus the sine of pi over 4 times the sine of pi over 6. Now I need to replace these values. The cosine of pi over 4, the x value right here is square root of 2 over 2. The cosine of pi over 6, the x value at this angle of rotation is square root of 3 over 2. Minus sine of pi over 4. So the y value there is 1/2. Sorry, pi over 4, square root of 2 over 2. This 4 looks goofy. Let's make it look really good. That's a 4, not a 6. And then pi over 6, that y value is 1/2. So square root of 2 times square root of 3 is square root of 6. 2 times 2 4, minus square root of 2 times 1, square root of 2, 2 times 2, 4. And so because these have the same denominator 4, I can put them over 4 and write square root of 6 minus square root of 2. So cosine of 5 pi over 12 equals this. That's the ratio in its exact form.